I joined CDOT because I was interested in open source development. I wasn't sure how it was possible to make money off software which you gave away for free, plus publish the source code. I was also interested at the time in 3D models because Skyrim had just come out, and hopefully most of you are gamers. But yeah, for those who don't know, digital content creation tools are used on mostly movies, games, and commercials right now. So long story short, if digital content creation tools didn't exist, we'd be back in the Star Wars era where people would be filming their models. Before I start explaining to you what the problems are with the current DCCTs, I'll tell a short story about Hazan over there, who Peter also introduced. As Peter said, he is a recent graduate, which means he is neck high in debt. And he also wants to be a game developer, which means that he's going to be up against the same guys who have made StarCraft, Warcraft, MapleStory, Battlefield 3, and also the giant AAA games. So his chances of finding a job, and it doesn't matter how smart he is, it's probably zilch right now. And so being the smart guy that he is, he goes off and makes, He goes off and makes his own company to create games. Now, the problem with that is he also has to create 3D models then, which means he needs a DCCT. So he goes off to his local software store and finds the most popular one, which I believe is 3ds Max. Well, it's one of the three. Then he finds out that it costs $3,675. And as I said, he's already in debt. So he goes off, scraps that idea, and is thinking, I can probably find something cheaper. Finds Maya, same price. So screw this, go on. Find something again called Softimage, and it costs the same price. So how exactly did this happen? All three pieces of software are currently owned by are published by
Autodesk.
Autodesk, yes, thanks guys. And because of that, they have a firm iron grip hold on the current market of DCCTs. And so sometime around this time last year, I believe, Ben, who's over there at Exocortex, pitched the idea of creating a cloud-based open source DCCT. Long story short, we're trying to take all of the strengths of the three DCCTs I mentioned earlier and strip away all of their weaknesses. Now, normally, DCCTs range in around 1.5 gigabytes to 3, somewhere in there, so they take quite some time to download and they also take time to install. So I'll show you guys right now how long it takes to install and download this software. Hazan? Done. Loaded, installed, whatever. So now I'll pass the torch on to Jesse, and he'll tell you guys what you're seeing on the screen.
All right, what you're seeing right now is our current. Right. Gotcha.
Can you guys hear us if we go really loud?
How do you?
Just clip on the recorder, and if you want to yell instead of using this, go ahead.
Okay. Okay. All right. So. What point? Oh. All right. Oh, okay then. So what you're seeing right now is our current prototype of the tool. So as you can see, you've got your 3 orthographic viewports and your perspective viewport, and you can maximize or minimize those. So you can move around the cameras in them and manipulate them, and you could also add certain primitives to the scene, like boxes, spheres, cylinders, and such. And you could also move them around. So those are the first things we tried to get into the tool. So as you can see, we built a bit of a web UI around that as well. We also created something called operators to change different properties of the geometry in a way such as 3ds Max's modifiers or Photoshop's filters. So as you can see, you can have a box and you could twist it around. So we're expecting other open source developers to pick these up, develop for them, extend the application a bit more, and hopefully it'll become a lot bigger. We also have material support in, which means you can change the color, add textures, change the opacity, and things like that. The general look of a mesh. As well, we've got lights that we can move around. We're also able to import and export from different popular formats like OBJ and Collada. As you see, this is all moving quite briskly. This is running in Google Chrome right now. It supports Firefox as well. So I'm going to give it over to Hassan here, and he's going to explain a lot of the more in-depth 3D stuff.
Thanks, Jess. Guess I'll take a minute to get the recorder.
Yes.
Sorry about the small delays, guys. Things that come inherent with presentations. Thank you, Kathy. So, thanks, Jesse. Just like I said, I'm Hassan. I joined this team a little while back to help out with some of the more mathematical aspects of creating a 3D tool on the web. So some of the things that I help with are some of the finer points of the manipulators that you saw already. So you saw move and you saw rotate, but actually quite a lot goes into them. So most 3D tools, or DCC tools I should say, are able to manipulate objects in world space and also in local space. So before I just go ahead and throw that on you, I'll take a minute to explain what that even means. So the idea behind the scene that you see behind me is that all the objects in that scene are inside of what we call the world space. So they all belong to the same space. The world space is characterized by a single point of origin, which is typically what is referred to as 0, 0, 0, and also 3 basis axes that go forward, to the right, and up. So the way that we identify the position and rotation of objects inside the scene is by keeping track of the difference in their position from the origin, and also the difference in rotation between that object and the origin. And the way we keep track of that is by taking the 3 axial vectors that each object has locally to identify their forward, right, and up, and keep track of the difference between that and the world space handles. So that's a lot of mumbo jumbo. Let me give you an idea of what that looks like inside our tool. So if Jesse would just click on something right now and just move it around in world space, you will see that the handles are aligned always in the same directions. They don't ever rotate. However, if we switch to local space move now, you'll notice that the handles have changed. So now, instead of just being able to move your object from, say, this point to this point, you could actually take that object and move it forward and back, left and right, or up and down, locally with respect to that object. So that's movement. We also have a world space rotation. You guys saw a little bit of that. That's quite interesting when you select a number of objects and rotate them all at the same time. So if we move, say, the box and the Buddha, you'll notice that they both rotate around a single point between the 2 objects. So that's how world space rotation affects groups of objects. So those are the 2 basic manipulators, move and rotate. We also have a scale manipulator, and this one is a little bit different in that it doesn't have a world space version. And the reason for that is simply because inducing a world space scale on a rotated object can do something called a shear, which would distort the rotation information stored. So we don't allow that. 3ds Max does, but we don't. We think it's cleaner this way. So what we do allow is local space scaling. So as Jesse will show you, we can take an object and stretch it along any one of its local axes. So again, that's the forward, the right, and the up. So with move, rotate, and scale, those are the three basic manipulators that we have access to in our tool. And that's basically what most other DCC tools have as well. In addition, we have lights and materials. We've covered those just slightly, just the basics a little bit before. I'll give you a better idea of what it actually means to have a material on an object. The idea behind a material is that it characterizes what the surface of an object looks and feels like. So you can see how shiny it is, for example. You could see how coarse it is. You can see what colors it has at any given point on the model. And that's what we call the material. And materials only have an effect when they interact with the light. So we showed you a point light before. So let's just take that point light that we had before, or a new point light, or whatever we can, and move it around some of our objects. And you'll see that the specular highlight, those are the, you see all the little white dots on the Buddha? We call that a specular highlight. Well, I guess the Buddha is a little too far away to to be affected by the light. But you'll notice that as we move the light around, the objects around it are affected. So a point light is a light that radiates light in every direction, and it's quite basic. The other kind of light that we have is a spotlight. And the way that a spotlight works is that it projects a cone of light from a single point of origin. And we see what the effect of that light is when that cone intersects with another object in the scene. So it produces a sort of spot, which may be a little hard to see if the material of the object is all white. So I don't know if we'll be able to see the spotlight with that. Oh yeah, that's a little bit better. Yeah, so you see at the corner over there, the little effect of the spotlight. So as we move it around, you'll see that the actual, the circle that identifies the intersection is actually moving around the light. So that's a spotlight. We also have directional lights. And directional lights are in some senses more basic than the others because what a directional light represents is an infinite number of parallel light rays hitting every object in the scene. So essentially, with a directional light, it doesn't matter where it is positioned. The only thing that matters is its rotation because that affects the direction of those rays. And what those are good for are simulating sunlight and things like that. So with those three light types, point, spotlight, and directional lights, we have the three basic lights that most DCC tools have. So the last thing that you can add to a scene as far as object types are concerned are cameras. So in most DCC tools, cameras are pretty much exactly what you think they are, just a camera that identifies, that lets you see through it into the scene. So those can be used for two things. They can be used just to capture a particular view of the scene and switch between different views. Or it can also be used to produce an animation or a film because you need a moving cameraman, essentially. So at some point, we plan on implementing animation timelines. And at that point, you'll be able to track a camera against a timeline and change its position over time and also peer through it. So that should be quite cool when it's done. So with those, we have cameras, we have lights, we have our objects, we have our importing, we have our exporting. And really, those are the basic aspects of our DCC tool as it stands. In the future, we plan on implementing sub-object editing because you'll notice right now we have all manner of different objects, but for example, you can't go into an object, select one particular vertex, so like the intersection between like the grid lines of the mesh, and say move it around, or delete it, or add new ones, or change the topology of the model. You can't do that yet. So we're actually working on that right now. And we'll also be changing the UI of our tool. You'll notice that at the moment it is quite beautiful, but we think that it needs some work. So we'll be moving from our current set of just HTML and CSS over to Dat GUI. So this right here is actually a screenshot of some of the work that we've done so far. You'll notice that our little editing panel is a bit prettier, and all the GUI is better put together. We think, we hope. Still under development, obviously. Nothing is complete or concrete about this. So aside from that, we're also changing the structure of our application. Initially, we started with a very basic prototype. And at some point, we moved over to, once we decided this was a decent enough application, we built essentially a bigger prototype, which took quite a number of months. And this is really where we're at right now. And moving forward, we're refactoring our application to resemble other Node.js applications, because we do want a lot of developers to work on this with us. Like Jesse said, we can't implement all the operators that we want and the manipulators and everything else. They have quite a bit of work still to do. So we're refactoring our application to look a lot more like a Node.js typical application, and hopefully that'll help people get started and be more familiar with with the structure of our app. Aside from that, our partner ExocorteX actually also has some plans to commercialize some of the rendering backend for this application. So without further ado, I'll let Ben talk a little bit about that, if he'd be so inclined.
Thanks. That's been an amazing presentation. It's incredibly impressive what you guys have built here. What we're trying to do with ExocorteX is we're looking to take this technology and implement it as a cloud-based service. And so that's what a lot of our focus has been on recently. And yeah, we're looking to have an open source front end that will simplify development of plugins and all the other features that you use within the GUI. And then we're looking to provide a bunch of managed services to allow you to collaborate with other people, manage your data, access rendering simulation, and possibly even sell your plugins through this framework. So that's what we're doing. Awesome. And it's coming along incredibly quickly. Like, I think the team, everyone together, it's phenomenal. So.
All right, well, thanks, Ben. This is pretty much our presentation. We hope that you enjoyed it. Are there any questions?